Large language models, LLMs, are advanced AI systems trained on vast amounts of text data to understand and generate human-like language. They use deep learning, specifically neural networks like transformers, to process language by predicting the next word or phrase in a sequence. LLMs can perform tasks such as answering questions, writing essays, translating languages, and even generating creative content. They are large because they have billions of parameters, the weights in the neural network, and are trained on diverse data sources to capture a wide range of linguistic patterns and knowledge. In this video you will learn how to fine-tune a large language model for a specific task. Fine-tuning a large language model involves taking a pre-trained model, which has been trained on a large, general dataset, and further training it on a smaller, task-specific dataset. This process tailors the LLM's knowledge to perform a specific task more effectively. In the notebook we will use the T5 model and we will fine-tune to read and summarize news from the web. It was firstly introduced in the paper Exploring the Limits of Transfer Learning with a Unified Text-to-Text Transformer by Colin Raffel et al. And it is designed to treat all NLP, natural language processing, tasks as text-to-text tasks. This means tasks like translation, summarization, classification, and question answering are all framed as converting input text to output text. Let's start by importing all needed libraries. We will mainly use Torch and Transformers for training and importing the model and the dataset. We will use the CNN Daily News from Hugging Face. The CNN Daily Mail dataset is an English-language dataset containing just over 300,000 unique news articles as written by journalists at CNN and the Daily Mail. Just for demonstration we will consider a small sample of the dataset for training since for this video I've only CPU available. I've however trained on the cloud with GPU and we will see in a second part of the notebook how to use it to summarize articles. Indeed, as I've explained in the intro, large language models have millions of parameters and they need an enough powerful GPU to be trained. We can load a pre-trained model, in this case the T5 model from Hugging Face Lib. We will use the small version which has much less params but still pretty good performances. The T5 model uses a standard encoder-decoder transformer architecture. Encoder takes an input sequence and processes it to generate a sequence of hidden representations. Decoder takes those hidden representations from the encoder and generates the output sequence, which could be a translation, summary, or any other text output depending on the task. The T5 tokenizer is responsible for converting input text into a format that the T5 model can process. Specifically, it transforms text into token IDs, integers, that represent the individual subword units or tokens in the model's vocabulary. Likewise, it can convert the model's output, a sequence of token IDs, back into human-readable text. T5 uses a sentence piece tokenizer as its base, which is a subword tokenization method. You can check the available devices on your laptop with the following cell. Let's now look at the dataset. We can print the first three elements. Basically, the dataset contains complete articles alongside very small summaries. We will have to tokenize the dataset. This can be achieved by mapping it with a function that we have previously defined. In this way, the dataset will be converted in a format that is understandable by the LLM model. Let's now go to the training. We will have to define firstly all the training arguments. Let's break down the function. The output_dir is the directory where the trained model, checkpoints, and other output files will be saved after each evaluation or at the end of training. Evaluation_strategy equals epoch. This determines when evaluation, validation, occurs during training. Epoch means the model will be evaluated after each training epoch, one full pass over the training dataset. Other options include steps, which evaluates at specific intervals, or no-for-no evaluation. Learning_rate controls how much to adjust the model's weights with respect to the loss gradient. A lower value results in smaller weight updates and slower learning, while a higher value speeds up learning but can cause instability. 5 times 10 to the power of -5 is a typical learning rate for fine-tuning large language models. Per_device_train_batch_size specifies the number of training examples to process per device, like a GPU, in one forward-backward pass. per_device_evil_batch_size similar to the training batch size. This is the number of samples processed at a time during evaluation, validation, per device. Num_train_epochs, the number of complete passes over the training dataset. Weight_decay is a regularization technique used to prevent overfitting by penalizing large weights in the model. Logging_dir, the directory where the logs, like loss values, evaluation metrics, etc., will be stored during training. These logs can be used for monitoring the training process. In the next cell for training we're going to define another class, data collator for sec2sec. The data collator for sec2sec is a utility class provided by Hugging Face's Transformers library, designed specifically for preparing data when fine-tuning or evaluating sequence-to-sequence, sec2sec, models, such as T5 or BART. Its main role is to process a batch of input data, text pairs for translation, summarization, etc., and prepare it for training or evaluation by handling tasks like padding and attention mask creation. This is crucial when using variable-length sequences in a model that requires fixed-size inputs for batched processing. We will have to initialize the trainer by specifying the params defined before, the data collator, the tokenizer, the train, and evil dataset. Let's then train the model. When the trained will finish, the model will be saved at a specific path. We're not going to train the model since it will take hours and we have trained it before. In the next section we're going to test the model. For that let's define two small news and let's see how the model translate them into a summary before and after the training. Before training we can observe that for both news, the model will capture some info but will not be able to enclose them in a good summary. Let's now load the trained model and the tokenizer. We can see how the model has learned in both cases to summarize the news by grasping the main information contained in the articles. In the next cell we will see a real application in which we will scrape the information from some predefined URLs. For that we will need two extra libraries, requests and newspaper. I've also defined some utility function to read the text from the URL, then if we fed our model it will translate the input text to a summary. We can observe two perfect summaries of the input articles. In the next cell we can do even better. We can create a small application by means of Beautiful Soup and Google News libraries. Beautiful Soup allows to do some advanced scraping from some URLs while Google News allows to query Google News for some specific topics. Here we'll search for news related to AI technology theme. Let's run the cell. We will have the more recent news and some additional information, the article title, source, publication time and the link to the article. In the next cell if we read the text from the retrieved links and we give it to the model it will create a short and precise summary. Note: this is a very simple program and sometimes the retrieved URLs contain some query params and don't allow to access the article. For these cases an exception will be raised. Let's take some time to explore the generated summaries. Finally, we can build a Python script that receives as input the query params and it will return summary of the news found. You will find the notebook as well as the Python script on my public GitHub repo. Let's test with medicine and finance themes and have a quick look to the output. We have arrived to the end of this lesson in which we have seen what is a large language model and how it can be fine-tuned for our purpose. I hope you have enjoyed this video, and let's see in the next one.